This is the first in a series of videos in which I'll be attempting to repair this machine. It is of course a Wren Executive computer system, and I say of course because anyone that is a regular viewer of my channel will have seen me posting videos on another of these machines recently. And that particular machine, I think I've repaired it. I'm trying to resolve an issue with the boot discs, and while I'm trying to resolve that, I thought I'd just try and have a look at this machine and see if we can get it up to the same state, so that if I can resolve the boot disk issue, at least then I'll have a dual result and get both of these sorted out at the same time. So this was dropped off by the owner a week or so ago, and I haven't dismantled it. This is how it was when it was dropped off. He's done some of the hard work for me and got the outer cover off, and it's in reasonable condition. It's actually quite good. It needs a good clean, of course. One question I was asked a few months ago, because I tend to work on so many projects at the same time, is how I keep track of all the parts and make sure that all the correct parts go on the correct machine. And why do I work on so many projects at once? I'll answer the second part of that first. The reason I work on more than one project at a time is quite often I have to wait for fairly lengthy periods to resolve particular issues. So for example, the boot issue I'm having with a couple of machines I'm working on at the moment might take a month or so to resolve, and while there may not be a great deal of work involved in doing that, I don't want the machine sitting around taking up space on the workbench and me being idle for a month. So I tend to put them to one side until I can make progress on them, and in the meantime I'll work on something else. In terms of how I keep track of all the parts, whenever a machine's dropped off, the first thing I do is tag it. So I'll give it basically what is a job number, and for a particular machine I then create a sheet of labels. These are special labels, they're peelable, so they're not permanent. I can stick these on, they won't fall off, but they'll peel off without leaving a sticky residue. And then I just label a few bags up so that I can keep all the parts labelled, so any screws that come off this, any fittings, brackets, that sort of thing, will go into their own labelled bag, and then I know exactly where each part has come from. Okay, so onto this machine. As I say, it's been partially dismantled. The owner tells me that it has been switched on, but even so I'm not going to power it up until I've had a look at the power supply. It may have survived the initial power on, it may have had some work done to it, but as I've said previously, I always assume that something's going to explode if I don't check it. So first thing to do is I'll get the top cover off and we'll have a look inside and see if the power supply needs any attention. Okay, so that's the bracket removed. We'll have a quick look inside the machine and see how the power supply looks. So looking inside, the power supply did indeed need to come out. The primary filter cap was missing completely, and the two Y caps were the original reefer caps, and we all know what happens to those, so I've taken those out. I've replaced them with much higher quality, more modern types. Now, I don't know if it was the current owner that took these out, but it is better to take this out than leave it there. It doesn't need to be there for the machine to work. It's better, of course, if it is there. It stops noise getting into the machine, and it stops noise coming from the machine and getting back out into the mains. So it is better to fit it, but if you do replace them, make sure you use good quality X capacitor for this position and Y for these two. I've checked all the rest, all the other caps are fine. Very rarely get problems with these caps, and the rest of the board seems fine. I've obviously cleaned the back, taken all the excess flux off it, and I just want to give it a quick test before I put it back into the machine. Now, as I've mentioned in previous videos, if you try and turn these machines off with no load on them, you'll just hear it ticking. It will sound like it's faulty. If you're familiar with switch mode supplies, then you'll know that a typical fault you'll get with them is they'll keep restarting. You hear it as a series of fairly rapid ticks when you power it up. So this is currently unloaded. I've got the mains going into it but no load connected. If I power it up, it's currently ticking. I'll move the microphone closer to the supply so you can hear it. So hopefully you can hear that. And if I put the meter across the 5-volt rail, then you'll see that it's giving us some fairly strange readings. So if I connect that up, you'll see that it's just rapidly cycling. And what's happening is it's going into over voltage shutdown. If I should turn the incoming mains down, it's about half now what it should be, you'll notice that the supply voltage on the 5-volt rail is now 6.3 volts and the shutdown is at 6.8. so if we go much higher with the incoming mains, then it goes into shutdown, and that's because there's no load on it. If I just simply attach a load, and this is just a few resistors, if I turn this back on and then remeasure the same rail, you'll notice that now we are getting just over 5 volts. If I turn the voltage back up on the incoming mains, so I'll go back up to pretty much what it should be, and then remeasure again the same rail, notice that we're pretty much at the same 5.2 volts, so it is working. I've checked all the other rails and they're all fine. There are 4 rails on this particular machine. 2 of them are floating with respect to each other, although there are some links that allow you to connect the commons together, and those links are actually in place. So the supplies are all common on here apart from one. And if we measure the rails, then we have the 5-volt rail, 15 volts, which is actually plus 12 but with no load on it, and then we have another plus 5 which is used as a minus 5-volt rail, and then we have the 12-volt rail, which is the one that I have the load on. So you can see that's working fine. I'll bolt it back to the chassis, get it back inside the machine, and then we'll flip the machine over and look at getting the main PCB out of it. I've reinstalled the power supply, refitted the screen, but one thing I've noticed on this machine is there's some sticky tape in here and just a piece of wire. This is the mains live coming in from the main socket. It should go to this fuse holder, but the fuse holder insert is missing, as of course is the fuse. So I'm assuming that because this was missing, somebody's just bypassed the fuse holder with a wire link. This is a definite no-no on these machines. You may have noticed that if you turn these machines off and then you switch them back on within a few seconds, they normally crash, or at least fail to boot up properly. And the memory, especially in these machines, is very susceptible to damage if the supplies are cycled rapidly. And of course, this being loose, all bets are off. The mains is going to be flickering on and off very rapidly, and this can easily destroy the machine. You can do an awful lot of damage to the electronics with this sort of arrangement. And in fact, this is quite often what causes damage when the capacitors on the supply fail. When they go short, it's effectively making the mains flicker on and off before the fuse blows, and that's normally what does the damage. So I'll get rid of this. I've made up a link with proper connectors on the end. I'll get this installed. I'll find a replacement fuse holder at some point, but because I'm powering this from the auto transformer, then it's safe for me to run it at the moment without the fuse holder, but definitely needs the fuse holder replacing and an appropriate value fuse putting in there. So I'll get this out of the way, and once that's done, what I'm actually going to do is try powering this machine up. Again, not something I'd normally recommend, but as I say, the owner has powered it up, and once I've got this arrangement sorted out, then I think it should be reasonably safe to power it up. It's unlikely I'll do more damage than has potentially already been done, and we'll see what the current state of play is. Okay, so I've put the wire link in. It's nice and secure now. I will put insulation boots on these when I fit the new fuse holder, but for now I've just left it exposed. Got a mains cable plugged in. I'll move the camera so we can see the screen, and we'll try and power it up and see what happens. I'll turn the lab lights down so we can see anything on the screen, and I'll now power it up and see what happens. Okay, well, no smoke so far. It's drawing about 0.15 amps at 225 volts. I'll give it a little while and see if anything appears on the screen, so no sounds. Screen is now lighting up. I will try and turn the brightness up a little bit. In contrast, make sure we haven't got everything turned right down. Okay, nothing there so far. I'll try and reboot the machine and see what happens. Okay, exactly the same thing. I'll move the camera so you can see the keyboard. Okay, and if you recall, what should happen when we power this machine up is the caps lock light should come on while the self-test is being performed, and then if there are any errors, then the power light at the back here should flash to indicate the particular error code. So I'll recycle the power, give it a few seconds just to make sure it resets. Power it back up, and as you can see, absolutely nothing at all. So it looks like it's completely dead. The processor board is not starting up at all. So we'll turn it over, get the bottom panel off, and have a look at the main board. So as you can see, I've got the machine turned upside down. The two screws that hold the base on have already been removed. So there should normally be a screw in this hole and another one in this hole. And then the base plate should just slide off towards the rear. This one won't slide off, and it's because the left hand insert has been pulled up into the hole that the screw normally goes through, so the plate can't slide past it. It's just the brass insert that normally sits inside the plastic moulding. The easiest way to get this resolved is to take one of the case screws, these are the longer screws, screw it into the brass insert, it's quite a long way into it, and then just gently tap it back into the plastic moulding. This one's quite badly wedged, so hopefully we can get the screw in. So it needs to go in about 3 or 4 turns, and then all you need to do is just gently tap it. If you're going to hit it hard, then stop. But okay, so the insert has now slid back into the plastic. Now it doesn't need to be very tight because it's not trying to hold the plate down, it's just trying to stop the plate sliding backwards. So it just needs to be gently resting in the hole that it's supposed to be in, but it needs to be all the way in, otherwise you can't slide this plate towards the rear of the machine. So we should now be able to slide this plate backwards. It's quite difficult on here because the machine's been separated, so it's a lot easier to do this when the machine's in one piece. If I now start trying to slide this, it should move towards the back reasonably easily. Okay, so that's started to move. We now need to turn it the other way up because there's a ground strap that's screwed to the rear of the case, and we need to undo that because you can only slide this plate so far until you undo the ground strap. So I'll just turn the machine back over, and as you can probably now see, there's a ground connector down here, and we need to disconnect that before we can take the chassis all the way off. I'll slide it a bit further forward to give us some more room, and now I'll just unscrew this nut and we can take the strap off and remove the plate completely. And they go into the appropriate bag, and we can now take the chassis plate all the way off, but again I'll turn the machine the other way up before I do that. Okay, I should now be able to slide this all the way off without having to disconnect any more wires. Which I can, and get that out of the way. Now I have a number of these about, so I'll give it a label. And the next thing is, obviously we can't really see much from this side of the board. One thing that concerns me a bit is there is some liquid on this end, so possibly there's some liquid damage on this machine. Another reason to always clean them before they're powered up. So I'll take the board out, we'll have a look at the other side of it. Now in theory what you should be able to do with the Wren is just remove these 3 screws, and this board should then hinge up, but the wires are far too short, and in general it's not practical to do that. You do have to take the board all the way out, but we'll give it a go on this machine and see if they're any longer than the previous one. And again, they go into the correct bag. And in theory this should hinge up, but it normally only goes so far before the wire snags, which it does, so I can't lift it all the way up. So I'll disconnect the wires, we'll pop the board out completely, and again to do that I need to also remove the keyboard. It's a bit of an odd arrangement. If they'd made the wires 4 inches longer, you could have hinged this all the way open, so again a good idea but badly executed. But I'll get this out, we'll get it onto the bench, and then we'll have a closer look at the main board. Okay, I've got the board out and onto the bench. Luckily, of course, I already had the extension made up for the previous one that I repaired. As I've been removing all the parts, I have of course been labelling them so I know which particular machine they go back onto. And we can now boot this up with it in its current state. And the first thing I want to do once we've got some power applied is to see if we are indeed getting the right voltages appearing on the supply socket. So I'll get it powered up and we'll just check those supplies and make sure they're correct. So we've got ground here on the left, the first 2 pins are ground, the next 2 should be 5 volts. Which they are, and then we have 12 volts, and then we should have minus 12 volts, which we do. So that's all looking fine. The next thing to check is pop the RAM out and make sure that's working. The screen's still showing nothing of any importance on it, so it's still not running. So I'll power it back off. I'll just grab my DRAM tester. So I'll just get the first one. And I'll pop that into the tester. Press the button. Just make sure it's properly seated. Try it again. And that one looks like it's failed. I'll grab the rest and see if any of them work. Okay, I'll have them all removed. We'll just check them all one by one. So we know the first one's failed. As has the second one. They do normally fail in groups, so it's rare to see just a single failure. And that one's failed. And all 8 have failed. I strongly suspect this was caused by that loose piece of wire going between the main socket and the main switch, where it was bypassing the fuse holder. If it's been cycling the power supply on and off rapidly, then that can definitely cause this sort of failure. What I'll do is I'll check the rest of the board over. There's some corrosion I want to clean off here. Looks like the battery's been leaking. Get that cleaned off. And then if I can't find any other faults, I'll try a new set of DRAMs and see if that cures the problem. Okay, so I fitted a new set of DRAMs and cleaned up the board. It needs a proper clean, but I've got rid of the worst of the corrosion, so at least there are no potential shorts on the board anymore. There was quite a lot of conductivity on the board around the battery. The battery will need to be replaced, it's completely dead. But once I'd replaced the DRAMs, I was starting to see some activity from the processor. And if you've watched my first series on the first Wren that I repaired, you'll know that the Wren carries out a built-in self-test when it's powered up. During the self-test, the caps lock light on the keyboard is illuminated, and then the power light, if a fault's detected, will flash a code depending on the particular fault that's found. Now once I'd replaced the DRAM, the caps lock light did start to come on for a few seconds each time I reset the machine. So if it's doing that, that's generally under the control of the processor, but more importantly it went out, which is almost certainly under control of the processor. But the power LED was showing nothing. It wasn't illuminating at all, so it wasn't indicating any faults. I did a continuity check between the connection on the keyboard through to the main board, just to make sure that there was no break in the ribbon cable, and that was fine, but I was still seeing nothing on the actual LED. And after a bit of head scratching, I decided to remove the DRAM for the video. So this DRAM is for the main system, and the DRAM in the corner over here is the video RAM. And the point of doing that was the DRAM for the video is checked fairly early on in the self-test process, and if the self-test is proceeding as it should, then the test should fail more quickly. In other words, when I reset the machine, the caps lock light should go out more quickly, and it did. But I was still getting no indication on the power LED as to what the particular fault was. So after a bit of head scratching and looking around, I noticed that the LED on the keyboard was loose. It was, if I touched it, it would move side to side, and then looking more closely, realised that one of the pins was snapped off. So looking at the orientation, I put a new LED in, and I was still getting no indication on it, so that was a bit confusing. And then after tracing through the circuit to see what was going on, I found out that the original LED had been put in backwards. So really confusing. It's I can't imagine it was like that from day one, but I've definitely checked it. I've even checked my reference photographs, and it was definitely in the wrong way around. So what I've done, I've taken it out, and just for the sake of the videos, I put in a 5mm LED so it can be seen more clearly. It should be a 3mm. I'll swap it before I reassemble the machine. If I now reboot the machine, we should see the caps lock light come on during the self-test, and then any faults should be indicated on the power LED. I'll just dim the lights in the workshop so we can see what's going on more clearly. I'll now reboot the Wren, caps lock, and 2 flashes, and it will just keep repeating the error code. So I'll reset the Wren, caps lock, 2 flashes. So it's failing with an error code of 2. Turn the lights back on. If we check the Wren manual, we'll see that that corresponds to video RAM failure, which makes sense because I've taken the video RAM out. So what I'll do now is put the video RAM back in and see if we get any further through the self-test now that the LED is showing something. So I tried a new set of video DRAM, didn't make any difference. I still get the same failure. So what I'll do now is start tracing around the board and looking for why the DRAM test is failing. I do get a successful test of the system DRAM, because if I remove one of the system DRAM chips, I get an error 1, which is walking bit test failure on the common DRAM. So I know the common DRAM's working, but the video DRAM isn't, and I suspect there's a buffer somewhere not working, so I'll track that down, get it replaced, and then hopefully in the next video we should be able to get a bit further through the self-test.